Welcome. In this video, we're just going to simplify our scalar triple product property of the cross product so that it could be computed using a single matrix. Now, this was a giant mouthful of words, so all I really mean by this property here is the dot product of one vector A. Actually, I should stick with using the same names as vectors that we have, so that is vector U, its dot product with the cross product of vector v and w. So that's what we're going to simplify. Well, this is, before I do that, for each of these vectors, that is for any vector, say vector A, I'm going to write this as A1, A2, A3. So for any of these vectors, I'm going to write their components with subscripts. So I'm going to do that for u, v, and w. So this is u1, comma u2, comma u3, and the dot product with this, the result of this matrix, I, j, k. And I'm going to overkill on the notation here, so let's just stick with that. And so this is the cross product of v and w, so we want v1, v2, v3, w1, w2, w3. So u1, comma u2, comma u3. And this cross product here is going to be v2w3 minus v3w2, comma, negative v1w3 minus v3w1, comma, v1w2 minus v2w1. There we are. And now I did not show the specifics on how to compute this cross product, so if you don't see how I got from here to here, please pause your video and work this out independently before you continue with the rest of this video. Okay, so this is u1 times v2w3 minus v3w2. Now, I have a negative in front here, so I have positive u2 times a negative, so this is negative u2 v1w3 minus v3w1. Finally, plus u3 v1w2 minus v2w1. So we can rewrite this as a matrix. What I mean is if I put u1 here, notice if v1 is here, that means v2w3. That's this product here. And we would have w2v3, this other product in this direction. So let's go ahead and do this. v2w3, again, that would be this product when computing the cross product, minus the product of w2 and v3, that's this diagonal here. Let's see if this actually works for the other parts here. So now we always subtract the middle component, and we have a minus u2, so that works. And we don't need to include v2w2. Those would be covered up. But notice v1w3, that product would be here. And then w1v3, that would be our w1 times v3 here. And now finally, if we put u3 here, go ahead and cover the values below u3, and you see we have the product of v1w2 minus the product of v2w1. So when computing this triple scalar product property, you can use this single matrix. Please keep calm and math on.